Today we are discussing about the flywheel experiment. Here we are just hang the weight to that axle. Due to the gravitational force and weight of that pan, they will try to move the axle. For that, it will convert it into torque, and a torque is nothing but means circularly the wheel will move continuously, and whenever your torque finish, end of the torque, the flywheel will stop. Now this is the vernier caliper, and use of this vernier caliper for this particular experiment to measure the, this is the axle's diameter of that, and we have to find out the radius of that. Okay, before that, finding the diameter of the axle, before that you are going to use that this vernier caliper. That's why you should know the least count of that. Okay, so now least count of that vernier scale is, this is the main scale. Okay, this is the vernier scale, just moving here and there. This is vernier scale. The main scale is 0.1 centimeter divided by here. Now vernier scale is the 10. 0.1 divided by 10 is nothing but the 0.01 centimeter is the least count of this. And using this vernier caliper, you can find out the diameter of the axle. Okay, you take the 4 different reading here, 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 and here. Add the reading values divided by the how many readings you have to given. You will get the mean of diameter of the axle. Okay, now again, whatever the value you will get for this axle diameter, divided by 2, you will get the diameter. After that, one important parameter is the pan, to hanging the weight for that. Okay, this is the thread, this is the aluminum pan. Okay, now you have to take the weight. You have to first you weight for this thread and pan by suitable electronic balance. Okay, and then you have to continuously mass in a pan. Whatever the weight you have to put, this is the weight of this. Okay, so this weight you can put on this, and you have to add this total weight. Okay, here mass of the pan 50 gram, 40 gram, 20 gram, 70 gram, all other things. After that, total mass of means this pan and whatever the weight put on that. Okay, and after that I will explain this remaining part at the time of the practical. Okay, thank you. Start. This is the flywheel. Here are the 2 bearings, and this is the axle. Okay, your aim is to find out the diameter of this axle. So you will have to put your vernier in this fashion. Okay, and now you take the reading. This is the one position, this is the second position, this is the third position. At least you have to take the 4 readings and write down. Once you get the diameter divided by 2, and you will get the radius of that. Okay, so easily you can find out. Now come to the main experiment. This is the pan. So you have to give the rotation to that. Okay, here is the sum of the provision to hang the weight. Okay, you just, this is the thread. Okay, you have to take in this fashion and rotate it. This is the 1 turn. Okay, in this fashion you just count this turn. First, this is the second, this is the third, this is the fourth, fifth, sixth, 7, 8, 9, and 10. Okay, so now once you have to give the 10 rotation thread to that axle, and now you put the weight of to the pan. Right now I am putting a putting 30 gram, 20 and 10, okay, 30 gram weight. This is the actual weight plus total weight, this pan plus this weight means your 38 gram, 38 gram of that weight is there, okay. So now I will just remove this, okay. Because of this weight it will try to pull down. You just see this, okay, in this fashion it will pull down. Once it will be break from this axle, this thread will break, that time the rotations will be formed. That rotation you have to count the rotation simultaneously, how many rotations and time period both should be measured, okay. So now here you use this digital meter for this, using the time, measure the time. Right now you just see here, okay, it is start to rotate that thing, okay. एक मिनट. And now the thread will come down. Immediately you have to start the count and measure these rounds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, okay. Now after removing this pan or thread, then you have to count, we have count these rotations, and near about 31 rotations are coming, and now it requires the time. You just see the time. Time period for this 31 rotation is 1 minute and 13 seconds, means total 73 seconds time period has been measured, okay. Now 2 times you have to take the reading, okay. Again same procedure you have to repeat, okay, for the same weight. Again you measure the rotations and measure the time period for their total rotations, okay. And once you will get, after that you have to reduce the increase the weight of the pan, 10 grams increases, okay, up to 60 milligram you have to take the weight and measure the rotations and other things simultaneously, rotation as well as the time period, and you note down on your observation table, okay. Come to the observation table, right. Now here the mass attached, see here the pan of the mass of the pan 7 gram and total mass 30 plus 7 is equal to 37. Now first time how many revolutions you will get? 31, okay, and its time required for 72 seconds. Now again put the same weight, that time you will get the 33. I got 33 revolutions, and time period is nothing but the 73 second. For this will be the same second reading, the 7 milligram will be the standard, plus I am increasing the 20, no, 10 milligram to that, here 40 plus 7 is equal to 47 milligram, and then I got the time period, number of the rotations will be 35, and time period is near about 76. Okay, in this fashion you have to increase the weight 10, 50, 60 and 70. Okay, and you measure this. So now find out the mean of these both, number of the revolutions mean and number of the time periods mean. You add both the values, both the values divided by 2, you will get the mean value. Again time periods mean you have to calculate here. Okay, now come to the point, n by t square. What is that n? N is nothing but the revolution. For this particular weight, whatever the mean value you will get, and divided by the time mean, and square of that value you will get the n by t square. Okay, now you have to calculate the alpha, 4 pi n dash. N dash is nothing but your how many turns of the strings around the axle. Axle ko whatever the string rounds, for this strings to the axle, that will be nothing but the 10. This value is the 10, 4 pi, and after that whatever the value you will get this, so you have calculated the alpha, and now your last m is to find out the torque, the mgr, and that will unit will be the dyne per center. Capital M, this is the total weight, pan plus putting the pan and whatever the weight you are putted on the pan. Okay, that thing. G value, all are gram and centimeter, that's why 980, and this r is nothing but the diameter of the radius of the axle. Okay, radius of the, and you will get the value. Okay, now after that all these calculations. Okay, now again you have to plot the graph. Here alpha's value on x-axis and your torque is on y-axis. When you plot the graph, draw the line and calculate the slope. Here BC, this BC divided by AC. Okay, whatever the slope value you will get here, and that will also nothing but the flywheel slope, grams per centimeter square, and here dyne per centimeter square up your torque will come. Okay, and this is the way you can calculate the frictional torque, dyne per centimeter. Which one? Dyne per centimeter. This is your torquenal force, frictional torque, and a moment of inertia of the fly easily you can calculate. I. Yeah, for this slope you will calculate. For this value it will showing the moment of inertia of the flywheel. You have to calculate that thing, and this is the way you can perform this experiment. Flywheel. Thanks. Thank you.